All right, so last time we started looking at equations in two variables, okay? That's what we were looking at last time. Now, we have equations, okay, in two variables, x and y. And just like we saw with equations in one variable, we can get to solutions of equations in two variables. Since there are two variables, basically what's going to happen is the solutions are not going to be just numbers. They're going to be ordered pairs of numbers. Okay? That's what I was trying to show you here on this slide last time, which if I remember correctly, I did cover. I also sent the notes through email, just letting you know. And basically, I did an example here. I think we did this last time where we had this equation in two variables, y equals 2x minus 1. And we saw that this ordered pair 2, 3 is a solution. These are not solutions. Mostly because if you replace the x coordinate, you plug it into x, and you replace y with the y coordinate, solutions will give you a true statement, but if it's not a solution, you'll get a false statement, and that's what happens here. And what's interesting about these equations in two variables, they will have infinitely many solutions, and I will show you here how you can actually obtain infinitely many solutions. Namely, you just let x be anything that when you plug it in, you get a number that makes sense, and then you solve for y. So you let x be any number here, in other words, and you calculate the corresponding y, and you get a solution. So if we let x be -1, right, we plug x and -1 in for x, we calculate y, and we get a solution. So this calculation shows us -1, -3 is a solution. Over here, same idea. If we let x be 0, then y, right, that's going to be 2 times 0 minus 1. 2 times 0 minus 1, which of course is -1, by direct calculation. So this shows us that the ordered pair 0, -1 is also a solution. This is a solution. And so on and so forth. You can actually do this for this equation here. You could do it for infinitely many x's. Mostly because if you replace x by any number, you will get something that makes sense. You just calculate y. And then we saw also that the graph of an equation is in x, y. The graph of an equation in the variables x and y is the plot of all the solutions. So if you were asked to plot the graph of this, sketch the graph of this equation, what you're really doing is you're sketching all ordered pairs. You're plotting all ordered pairs that are solutions to this equation. That's really what's going on. To actually make such a graph, I know we have technology today like graphing calculators. We have, we also have, computers and stuff. But it's good to be able to sketch it by hand, though. Basically, to sketch a graph by hand, of an equation by hand, you basically would make a table like this of solutions. You would plot the solutions, the ordered pairs, in the Cartesian plane. Then you would connect them with a smooth curve. You would connect them with a smooth curve. I mean, of course, the more points you plot, the more accurate your graph's going to look like. I mean, here we probably know already this is going to be a line. We'll see that in the next section anyway, 2.3. But that's how you actually sketch the graph of an equation. You just basically you plot a bunch of solutions and connect them, connect the dots, so to say. Okay, that's what happens here. As an example, we have this. So here, I think last time I got this wrong, that's probably where I left off, but I fixed it now. But basically, as you can see, right, we calculated a bunch of solutions, right, by replacing x by different numbers. We have -1. I don't think that's the same one. Oh, it is the same one, actually. It's the same one as on the previous slide. But basically, I plotted those solutions. I think I have an extra 2 here. Once I plot that point as well, I connect them, and we can get the graph of the equation. I mean, we know beforehand, you might have learned earlier, this is going to be a straight line. I mean, if we did not know that, this is what the graph would appear to look like. Again, we would have to get more solutions to get a more accurate graph. You know, the more points you plot, the more dots you can connect, and the more accurate the graph is going to look like. Okay. So that's what we have here. I mean, you can also graph it using technology, but again, it's better to be able to graph certain, you should know certain graphs by heart, so to say, like memorize, that is. All right, so we have that. Related to graphs, notice here, okay, over here, the graph is crossing the x-axis. Remember, this is the x-axis, the horizontal number line. That's crossing the x-axis here. The graph also crosses the y-axis at 0, -1. That leads us to the next definition, intercepts, x and y intercept. Basically, if you have a graph of an equation, the graph will intersect the x-axis. That point of intersection has to look something like this. That point of intersection has to look something like this, as you can see. Okay. Now, wait, let me go back to the other graph. I mean, you can kind of see that from here because this point here, okay, the y coordinate has to be 0 because you're on the x-axis. I mean, what that number a is, that depends on the actual graph, but it has to look something like this. And in a similar way, the y-intercept, it's going to cross the y-axis at a point of this form. You know, when you cross the y-axis, right, you're on x equals 0. You know, every point here has x coordinate 0. You know, if you were to ask the plot 0 something, you would not go anywhere from the origin, and you would just go up or down. Okay. That's why this a here, we call it the x-intercept. The b here, we call it the y-intercept. So intercepts are not actually points, they're numbers. And sometimes, and you can actually, depending on the graph, you can calculate the x and y intercepts. Basically, you set the other variable equal to 0 and solve for the remaining variable. So in other words, if you want to find the y-intercept, you're going to set x to be 0, and then you solve for y. Okay. If you want to get the x-intercept, you set y to be 0 and solve for x. You know, so over here, if we set x to be 0, we got y to be -1, so -1 is the y-intercept. We could calculate the x-intercept here. What we would have to do, though, is set y to be 0 and determine what x is. Although it's not that hard to do because we have y equals 2x minus 1. And that's actually what I do here. See? The x-intercept, we set the other variable y to be 0, and we solve for x. And that's exactly what I'm doing here. So basically, this point over here, let me see if I can draw it in. This point here is going to be of the form, let me see if I can draw it. Although I think this might make things worse if I draw it. -1/2. No, not negative, what am I saying? +1/2, comma, 0. Okay, so I'm trying to draw that point, although I don't know how successful I am, but I'm trying to draw what that point is. So it's 1/2, comma 0. Okay, so hopefully I was successful, but that's basically how you find x and y intercepts. So, okay. That's what we have here. Okay. So let's do it. Let's now get another example. So for instance, let's suppose now we have y equals 3x plus 4. Okay. So again, same idea. If you want to get the x-intercept, right, you set, excuse me, the y-intercept, that's what I meant to say. You set x to be 0. And if x is 0, 3x is gone, you're going to have 4. Right? It's always the other variable equal to 0. So for the y-intercept, x is 0. And we get 4. As you can see also from the graph, right? When x is 0, you're going to cross the, it crosses the, what do you call it, the y-axis at 4. For the x-intercept, you set y equal to 0, and you determine what x has to, you set y equal to 0 and solve for x. So for the x-intercept, you set y to be 0, and you determine what x is. Again, it's always the other variable. Y has to be 0. That's what we can use to figure out x here, the x coordinate of this point. And it turns out to be, see, I think that's a, yeah, that's a mistake. It turns out to be negative 4 over 3. Let me just fix that. So it's actually minus 4 over 3. Okay. So I just fixed that. Okay. So that's what we get here. And if you did negative 4 over 3, I think that turns out to be negative 1 1/3. So it is between negative 1 and negative 2. Okay, that's good. Okay. Let me just pause the recording. Okay.